Hey guys, this is Chemplified, and in this video we will talk about nucleophilic substitution reactions, and in that category we will talk about Sn2 reactions first. Sn2 reaction simply means substitution nucleophilic bimolecular reactions. So let's start. Now in Sn2, S stands for substitution, N stands for nucleophilic, and 2 stands for bimolecular. These are the two different names given for this particular mechanism. Now the most important points that you should remember about this particular reaction is, first one is that it is a single step reaction. Second one is it follows second order kinetics. Now the second here comes from this two. You can remember it like this, right? So the second order, it is a second order kinetics. Now to understand this particular reaction, we will take an example of alkyl halide, in our case methyl chloride. Let's start. Before we start, also remember this one thing, that Sn2 reactions are single step reaction, and Sn1 reactions, which we are going to study in the next video, are two step reaction. Remember this, Sn2 is single step and Sn1 is two step reaction. So 2 means 1 means 2 in nucleophilic substitution reactions. Now let's start with our mechanism. Now first our reactant is alkyl halide, in this case methyl chloride. Now this is a 1 degree carbon, first thing. Now OH here is behaving like a nucleophile. Now what is a nucleophile? Nucleophile is any species which have the ability to donate electron, or any species which is electron rich in nature, right? Now since it is electron rich in nature, it need an electron deficient species to donate its electron. Now where is that species in this particular case? Now chlorine here is electronegative, so since chlorine is electronegative, it will attain a negative charge, small negative charge, and carbon is going to attain small positive charge. So this is our electron deficient species in this case. So our OH will donate its electron to this carbon, and the attack will take place from the back side of the chlorine. The position where chlorine is present, the attack will be from the opposite side, right? Now in the next step there will be a formation of intermediate. Now what is happening in this particular intermediate? OH is trying to make bond with carbon, and chlorine is trying to break its bond with carbon. So two things are happening together with the formation of intermediate. Now after this process is complete, OH will form a bond with carbon and chlorine will leave as a leaving group, right? So this is the mechanism. Now the important thing about this mechanism is that the configuration of the reactant molecule and configuration of the product molecule are not same. In simple terms, the configuration has inverted. If chlorine is on the right side, the incoming OH group will be present on the left side in the product, and we call this configuration change as Walden inversion. So this is an important point. Remember what is Walden inversion? The change in configuration during the reaction with the mechanism Sn2, when the reaction proceeds through Sn2 mechanism. There is one more important thing about this reaction. Now this is a 1 degree carbon, that is primary carbon. Why we have taken the primary carbon, we will discuss this in detail after some time. But remember that only primary carbon will give Sn2 reaction. Only primary carbon will give Sn2 reaction super fast, right? Oh, sorry, this is a 0 degree carbon. There is no other carbon attached to it. So either 0 degree or 1 degree, either methyl chloride or primary alkyl halide will give Sn2 substitution. 2 degree or secondary carbon can give or cannot give Sn2 reaction. It depends on various conditions. We will discuss about that in separate video. 3 degree or tertiary carbon will not give Sn2 reaction, right? So we will also discuss the order, but remember only 0 degree or 1 degree carbon will give Sn2 substitution reaction, right? Now let's discuss the order. Now this is the order. If you are given the choices to proceed with Sn2 mechanism, the first choice will be 0 degree carbon, right, or methyl chloride. Second choice will be primary carbon. These two will definitely give Sn2 mechanism. Secondary carbon can give Sn2 mechanism, but it depends on various conditions, right? And tertiary carbon will not give Sn2 mechanism. Remember this, right? Tertiary carbon will not give Sn2 mechanism. Now the question is, why tertiary alkyl halide do not give Sn2 reaction? We will discuss this. The answer is, we know that Sn2 reaction is single step reaction, right? Sn2 reaction is single step reaction, and the leaving group leaves after the attack of the incoming nucleophile. When this nucleophile attacks the carbon, and then the leaving group starts to leave, right? This is the process. Now take a look at the structure of the tertiary alkyl halide. If you look closely at the structure, this tertiary carbon is attached to 3 different alkyl groups, right? Now this is the smallest molecule that I am presenting in front of you. Now the actual structure is not like this. The hydrogens are not so close. This hydrogen is not present here. The bond formation take place and hydrogen are somewhere far away from the carbon, right? Like this, right? Same for this carbon. Now this particular case covers all the space around the tertiary carbon. This space is being covered by the hydrogens present on the carbons, due to which the nucleophile which is supposed to attack the carbon is not getting enough space to enter this particular space and attack and reach the carbon to donate electrons, right? So this is the problem that the nucleophile have to face in tertiary carbon. So the single term that you should use to answer this question, why tertiary alkyl halide do not give Sn2 reaction, the single term that you can use is steric hindrance. Because of steric hindrance, the attack is not possible. The nucleophilic attack is not possible from backside. Now this is the smallest molecule. Suppose in place of CH3, C2H5 is present, right? Just one step ahead. So it means this carbon will be attached to another carbon, and CH3 will be there, and CH3 will be in this form, right? So this will cover a larger space. Suppose another C2H5 is present at this place, so this will cover a larger space, right? So further, as you increase the size of the molecule, the nucleophilic attack becomes more and more difficult. I hope I am clear. So that's why Sn2 reaction is not possible for tertiary carbon, right? And that's why order of reactivity is like this: 0 degree carbon, then 1 degree carbon, then 2 degree, and in the end it's 3 degree. And you also know the reason why 3 degree carbon do not give Sn2 mechanism. This will be it for today's video. I hope I am clear up to this. Thank you very much for watching.